All right, good evening, everyone, and thank you so much for joining us for Science Off Tap tonight. Give me a moment to get our screen in play here. Well, I'm Sadie Mills with the Thomson Earth Systems Institute, and I'm here with Chelsea Collison from the Florida Museum's Exhibits and Public Programs Department, and she's going to tell us a little bit more about our partners tonight.
Yeah, hi everyone. We're so glad you're here and joining us tonight for, I guess, our second Science Off Tap. And since we're here on Zoom, unfortunately, we're not sharing this evening with our favorite sponsors and partners in this program, which are First Magnitude Brewing Company and Cypress and Grove. So I hope at least some of you stopped by there, maybe picked up some brews on your way back home to your Zoom screen. And if you haven't, make sure to check them out sometime in the future if you're local here to Gainesville. They're some of our favorite partners to work with on different programs.
And now that I see we've got most people have filed in, some quick housekeeping. If you want to ask questions at any point, you can go ahead and type them in the chat. We'll have some time for Q&A at the end, but you can type your questions at any time and we'll be sure to keep track. And if you're joining us on Facebook, you can also type your question in the Facebook video chat and we'll keep an eye out for those as well. So we really hope that you'll join us for the entire series of Science Off Tap, Changes on the Horizon. Mark your calendars for October 8th for CSI Wildlife to learn all about wildlife forensics. And then November 12th for Mangroves on the Move to learn about those as well. And to see that full calendar, we'll be dropping the link into the chat so you can save the date for those.
Yeah, in addition to those awesome Science on Taps we have coming up, we also are partnering with the Alachua County Library District this fall and spring for the National Endowment for the Arts Big Read program, which is super exciting. So our first program with that will be the NEA Kickoff, which is going to be a lab blitz, an opportunity to meet 4 of our awesome women scientists here at the museum. And that'll be September 19th from 3 to 4:30 p.m. And I think, yeah, Elise just posted the link to learn more about those events there as well. So if we're not gonna be enough time to write these all down, the links are in the chat. So definitely check that out.
So wanted to quickly mention a new campaign that we're working on. There are millions of species of insects worldwide, but unfortunately, many of them are under threat due to habitat loss, climate change, and pollution. And these insects actually do a lot of services for us, including pollination, decomposition, and being a part of the food chain for animals we really like bats and birds. So to learn more about why insects are in decline and take a pledge to help protect them, you can visit our website. It's bit.ly/insect effect, and we'll also drop that link into the chat as well. At the end of the program, we're going to ask for your help. We always want to get your feedback to improve, and the more feedback we get, the better. So thank you in advance for taking just a few moments to fill out our exit survey. We'll put it in the chat at the end, but if you signed up through the Zoom registration, you'll also get an email with it later. And if you're in Facebook, we'll drop it in the Facebook event as well. So lots of opportunities to take it and let us know what you think. All right. Well, before we get started with our main event, we want to let you know that you can interact with tonight's presentation on your mobile phone or in another tab on your internet browser. You can go to www.menti.com and enter the code here on the screen, and that will allow you to vote and contribute throughout the program. So again, the website is www.menti.com, and the code is 2569296. And we'll also drop that in the chat so you'll always be able to see it. And as a bonus, every time that there is a question you can interact in, the website and code will be at the top of the screen. So I'll give you just another second to navigate, and then we'll go ahead and do some warm-up questions to make sure everything's working.
Thanks, Sadie. Ooh, looks like people are already voting. Awesome. So this is a short trivia game that I wanted to try to see if you guys knew. I personally do a lot of reading, and I always see all these different terms that describe both water and land. So I'm curious if you guys can choose all the words here that you might use to describe a body of water. So I'll give you a hint. 4 of them do, 1 of them does not. So see if you can go ahead and choose all of the ones that might be used to describe a body of water. And we'll give you all a couple of seconds here. If you're still looking for that code, it is still at the top of the screen. So menti.com 2569296. Looks like about 22 people have voted so far. You guys are awesome. Doing great, getting the answers. Y'all are smart. Awesome. Looks like we have about 29 people playing, and about half of you are on the Menti, but I assume some of you are watching in pairs or groups of 3 at home with your families. So all right. So yeah, I'll go ahead and give you the answer here. Yes, so canal, basin, channel, and stream are all words you might use to describe a body of water. And actually, a crag is not a word you might use to describe a body of water. It actually means a steep or rugged cliff or rock face. So now you know. Okay, we'll try one more time to give you all an opportunity to play again. Sadie, if you could advance to the next quiz question. And we will do one more. Okay, so the same game, same rules, new words. So we have tributary, dell, brook, rivulet, or confluence. So again, you're selecting all the words you might use to describe a body of water. And I'm waiting till get about 30 or so people answers in, because that's about as many as we had last time. And you guys are rocking it again, no pun intended. We're not talking rocks tonight. We're talking water. Awesome. All right. Yeah, you guys, you killed it again. So you are correct. Tributary, brook, rivulet, and confluence are all words you might use to describe a body of water. And a dell you would not use to describe a body of water. It actually means a small valley, usually among trees is what the dictionary definition says. So now you know, don't use a dell when you're looking at a creek or a brook. And you are ready to go. Talk about water, got your terms. So Sadie's gonna flip it back over here, and I'll see you guys again at the end.
All right, yeah, thank you, Chelsea. We'll have more opportunities to interact in a little bit. And again, if you didn't get a chance to, the code in the website or in the chat, and will also be at the top of every quiz question. Well, I want to take a moment to do a warm welcome for our speaker tonight. AJ Reisinger is an assistant professor and extension specialist in the Soil and Water Sciences Department at UF, where he focuses on urban soil and water quality. He majored in environmental science as an undergraduate at the University of Notre Dame, where he studied Pacific salmon streams in Alaska. He continued studying the effects of humans on streams and rivers for his master's degree at Kansas State University and for his PhD at Notre Dame. Following his PhD, AJ studied urban stream restoration in Baltimore, Maryland, and studied coastal wetlands in the Great Lakes. In 2017, he moved to Florida, where he's been working to better understand how urban development impacts water quality and ways to minimize those impacts. So we're so excited to have him here tonight. Give a nice round of silent applause as I turn it over to AJ.
Awesome, thanks. Let me just get my screen share set up here. Can you all see my presentation, PowerPoint? Thumbs up, maybe?
We can see it in presenter mode.
Okay, let me flip this around. Okay, how about now? Are we good?
Not yet.
Okay. All right, sorry about this technical difficulties. I'll just share the screen. And okay, and let's do this here. Sorry about this. Full screen.
All good.
All good? All right, cool.
Yep.
Sorry about that, everybody. The joys and perils of multiple monitors, which you would have thought I would have learned how to deal with about 6 or 7 months into a work from home epidemic. But regardless, my name is AJ Reisinger. I'm here tonight to talk with you all about urban streams. And urban streams, I think, are something that often get neglected or just ignored. People don't even realize there's a stream in their environment. But it's something that I think a lot about, and I'm hoping that after today's talk, you all will realize that urban streams are actually capable of doing a lot of work for us on the landscape, and there's ways we can enhance their ability to improve our water quality here in the state of Florida and beyond. So before we get into the meat of the talk and the science, I'm going to give you a little bit of a background about myself. I was born and raised in Nebraska, a small farming community in southeast Nebraska. So as a farm kid, I grew up kind of playing in the woods and walking beans and walking corn, picking weeds, all that sort of thing. Then I got so sick of the corn that I decided to move all the way to Indiana. You know, no corn there, but I got my undergraduate degree at the University of Notre Dame. And then after graduating, I moved to Kansas State University, where I got my master's degree, and then back to Indiana. So until I turned 28, the closest I ever lived to the ocean was actually the state of Indiana. It's kind of shocking now that I live in Florida. But I then moved to upstate New York for a few years, where I started working in these urban ecosystems. I've been here in Florida since August of 2017, so just over 3 years now. And I really have continued on my love of the outdoors. I love to go on hikes with my family. That picture on the right here is a picture of me with my daughter at Amicalola Falls in the Georgia mountains, just from right before COVID. We snuck in a vacation right before the outbreak happened, which was very lucky. During my PhD, I spent most of my summers floating rivers for work and for play. And so whether it's a kayak, a canoe, a boat, or an inner tube, I love spending time on rivers or springs. And I also just love I love being outdoors, but I also love being indoors. I'm not gonna guilt you into thinking that you need to spend all of your time outside to be an environmentalist. I sit on the couch and watch TV. I play video games. I love coding things on my computer, that sort of thing. So I do a little bit of both, and hopefully you'll learn a little bit, and I'll be able to translate my love for the outdoors and for the environment to you all. So now moving into the professional background, we're going to walk through my professional career and professional development really briefly. But as Sadie mentioned, I started as an undergraduate at Notre Dame, where I studied the effects of timber harvest in Southeast Alaskan salmon streams. So I was like a 21-year-old kid that was fortunate enough to get a paid summer work trip to Southeast Alaska, where I spent my time trapping salmon in these streams, which is awesome. And really, that's where I fell in love with stream ecology and working outdoors. As a master's student, I studied how the suppression of natural fire regimes and the removal of large grazers led to the expansion of woody vegetation and tallgrass prairie ecosystems, and what that means for nutrient dynamics of prairie streams like the one you see here. As a PhD student, I spent every summer traveling all across the United States, floating rivers and measuring nutrient cycling in these different river ecosystems, spanning really large, well-known rivers like the Colorado River or the Snake River, and then some of the more impacted agricultural rivers like the Tippecanoe that you see here, with a lot of row crop agriculture in the watershed. And finally, following my PhD as a postdoc and on to my time here at the University of Florida, I've been most focused on urban water quality and urban stream and river dynamics, but I've also been taking a step outside of the channel and outside of the stream and looking more up into the watershed to see how different human activities on the landscape are affecting urban watershed nutrient dynamics. So I've been lucky enough to work in a variety of ecosystems, really pristine places, really human impacted places, really beautiful places, some not so beautiful. Some of the Baltimore streams I worked in were not as beautiful, you know, but throughout my whole career and moving forward, I'm really focused on the effects of humans on stream ecosystems and how the things that we do on the land affect what flows downstream. So I've mentioned the term watersheds a few times already in this introduction, and that's intentional, and that's really important for today's talk because I'm going to talk about urban streams, but I'm also going to be talking about the things that we do in the watershed that impact those streams or ways that we can reduce those impacts. So to get us all on the same page, I wanted to just briefly walk through this definition of a watershed. A watershed is the entire area of land that all drains to the same single location. So if rain falls on any point in a watershed, that water will eventually reach the same outlet downstream. So in the schematic here, you can see that there's dashed lines demarcating the edges of the watershed. There's some agriculture in the watershed. There's an urban development. There's some forestry or industrial development in here as well. But no matter where rain falls on this watershed, it will flow across the landscape or through groundwater flow paths, eventually making its way into the stream network where it will flow downstream. And so to kind of continue on with the interactive feel of the presentation and to kickstart it a little bit here, I'm hoping that you all will go to Mentimeter and answer the question, do you live in a watershed, to see how you all respond. So let's see if I can advance that. There we go. All right. So waiting for about 30. Oh, I need to share the screen too. Sorry. So now if we look at the screen being shared, you can see that yes, about 90%, maybe not quite 90% of you all are recognizing that you live in a watershed. The answer is yes, you all live in a watershed. And the reason for that is no matter where you're from, everyone lives in a watershed. Even if you're going to call your home or the area you live in a spring shed, technically it's still a watershed. This map that I'm showing here, hopefully you all can see this. If you can't, Sadie, let me know. Figuring out the screen swapping again. But this map is showing all of the major watersheds throughout the continental United States. All the major watersheds are separated by different colors. The pink watershed throughout the entire Great Plains and Midwest, for example, is the Mississippi River watershed. The orangish color in the Pacific Northwest is the Columbia River watershed. The light green, yellow in the Southwest is the Colorado River. Then if you move down here to Florida, you can see there's not as many really large watersheds, but there are still some major river systems as denoted by the width of these different lines showing the size of the rivers. So we have the Suwannee River watershed, the St. Johns River watershed, the Kissimmee, the Lake Okeechobee watershed, etc. But regardless of what watershed you live in, those watersheds are encompassing all of the United States, and watersheds encompass all of land because that land has to drain somewhere. So it, by definition, is a watershed. And so if we think about what happens on a watershed, it's land, as shown here in this little cartoon schematic in light blue, draining into a stream network shown here in dark blue. So if we think about the different things that we could be doing on the landscape, we could have things like residential development leading to green lawns with some shrubs and some nice St. Augustine turf grass that we then have to irrigate and in order for our plants to grow, which is fine, which is great. But we might get an irrigation leak that might drain onto the sidewalk that then makes its way into the stream channel. By having that driveway and that road, we're changing how water moves across the landscape. We're reducing the amount that will infiltrate into the ground, and instead it will run off these impervious surfaces and more rapidly make its way into the stream and river network. Other things that happen in the watershed that are going to affect our water quality include agriculture. Everyone, I think, I hope, eats. You know, if you eat, you owe the food that you have on your table to some form of agriculture. So agriculture is not the enemy. It's not a bad guy, neither is urbanization. But it is important to recognize that the types of agriculture and types of urbanization do affect and change both the amount of water and the rate that water moves across the landscape, as well as the chemicals and other potential pollutants that are dissolved in that water and moving with it. We can move all the way down to a more downtown, hardcore urbanized site, like this picture from Hogtown Creek behind Lowe's on 13th Ave in downtown Gainesville. If I could take a picture of a smell, I would love to share it right here, but I can't. But suffice it to say, I think there's a sewage leak somewhere in this neighborhood because, yeah, if a smell could talk, it would. But the way that we're developing the landscape, the amount of concrete that we have, the amount of parking lots, that sort of thing, are really changing what's flowing across our landscape and affecting the water dynamics of a watershed. And that's important because eventually these stream and river networks make their way to sensitive downstream water bodies like the Tampa Bay, which is pictured here in the bottom right, where if they're bringing with them a lot of nutrients, a lot of other contaminants, they can lead to a variety of water quality issues. So we often think about this in terms of inputs from the landscape, and then they move throughout the watershed, and eventually they become outputs at the bottom of the basin. However, most people, when they think about water quality issues at a broad watershed scale, they'll view streams and rivers as a black box or a passive pipe or a simple transporter or conveyance, a way that water and whatever's dissolved in it moves throughout the landscape. Instead, what I do is I think about the processes that are affected within streams by these water quality issues. Things like nutrient pollution and heavy metals and sediments can alter the biodiversity of a stream or river ecosystem. It can change the amount of photosynthesis that's occurring. It can change the greenhouse gas emissions from a stream. But also the ecological processes in those streams and rivers can in turn affect the downstream water quality. So algae and bacteria and other microbes are really great at actually sucking up nutrients and acting as a natural filter to improve downstream water quality. So understanding the interactions between water quality and ecology and how they are affected by what we do on the landscape is really kind of the fundamental crux of what I do as a scientist. And I'm particularly interested in this watershed land use and human modifications as an urbanization component, or the component of it due to urbanization, because urbanization is one of the major global threats to the environment across the globe. So the picture on the left is just a beautiful shot of the Miami skyline, but on the right you see the global population from 1500 estimated up through 2016. And in red you see the rural population, and in blue you see the global population living in cities. As of 2008, more than 50% of the global population live in cities. And beginning in about 1950, more than 50% of the US population lived in cities. The most recent estimate that I saw from the 2010 census had that about 70% of the US population is are urban dwellers. So most of us live in cities, and those numbers are continuing to expand. So we're going to keep urbanizing more and more. So understanding how that's affecting our watersheds and our water quality is really important. And so to put this in perspective, we have another Mentimeter question that I'll advance the slide for right now, but I'm hoping you'll go back and answer or take your best guess to find out what % of Florida's population lives in urban areas. Okay, we're getting a little bit more variation here, not as obvious of an answer. So it seems like most people so far are thinking about 75 to 90%. Okay, seems like that's starting to be the answer. All right, I'm going to call it. So the group consensus is that 75 to 90% of the Florida population is urban. That would have been the right answer in 1960. 1970 maybe even, but as of today, more than 90% of the Florida population lives in urban areas, and that percentage continues to increase along with our increasing population size overall. So if we look at what that looks like from a land use perspective, the map on the left here is showing the population of Florida in 2010, which was 18 million people. As of last year, it was 21.5 million, so we've grown a little bit. But those 18 million people were predominantly living in the red areas on the map. That's the developed landscape throughout Florida. The dark green areas on this map are protected areas that will never be developed. So places like the Everglades National Park or state or national forests or other conservation areas. The light green is everything else, including agriculture, including rural acreages, that sort of thing. So everything that's not dark green on the map on the left could be developed. And the Florida 2070 project, which looked at projecting trends in Florida demographics and natural resources through 2070, estimates that there will be about 34 million people living in Florida by 2070. And the map at the right shows where they're going to live and what that's going to do to the land use. You can see that basically everything from Orlando, heck, even Gainesville South that isn't developed already is going to be developed unless it's protected for long term. So there's going to be a vast increase in the amount of developed land in order to house the more than 16 million people that are going to be moving here over the next 50, 60 years. So understanding what impacts these people and how they're living on the landscape are having on our water quality is particularly important. But why is it important? You might ask. Okay, so we've got urbanization, we might affect water quality. Why do we care? Well, I have the term nutrient pollution up here at the top. I should have talked a little bit more about that earlier, but one of the main issues with urbanization is increase in nutrient export from the watershed. And it's important to care about nutrient pollution and water quality for a variety of reasons. But in Florida in particular, it's important because of the dependence of this state upon tourism. In a typical non-COVID year, about 10% of Florida's gross domestic product is generated by tourism. There's more than 875,000 jobs supported by tourism in this state. And you can see in the chart at the top right that in 2016, it was estimated that about $112 billion were spent in total visitor spending. And there's a variety of reasons why people come to Florida. Granted, Disney World, Disney World isn't going to be affected by nutrient pollution. But a primary reason why a lot of people love to come to this state is the beautiful coast and the beautiful natural resources that we have here. Florida has more than 8,400 miles of coastline. That's the most coastline of any state in the lower 48 in the continental United States. Not only do we have a lot of coastline, we have a lot of really pretty coastline. So this picture at the right is just some example I found from a Florida tourism website, but I could show you a picture from a vacation that I took with my family and it would be equally beautiful. But nutrient pollution impacts water quality. It can lead to the development, continuation, or enhancement of algal blooms, both in freshwater ecosystems as well as off the coast. And so this nutrient pollution will reduce the quality of our beaches, will reduce the quality of our springs, will impact some of the other natural resources that we have that really are the bread and butter for the ecotourism industry of the state of Florida. Furthermore, beyond just dollars for ecotourism, human health is also a major issue with water quality in the state of Florida. In a large red tide event off the coast of Sarasota County about 10 years ago, there was an estimated increase in hospital visits that cost $22 million in annual health costs during that one single red tide event. And beyond that, individual cyanotoxin issues coming from freshwater or marine harmful algal blooms can cause human health issues or animal pet health issues. And that's been shown in more than 41 states and more than 50 countries across the world where there's been either a human or animal illness or death linked to cyanotoxins from harmful algal blooms. Beyond that, the commercial fishery industry of the state of Florida loses about $13 to $25 million every year due to harmful algal blooms. And beyond these things that we can actually put dollar values to, there are the less easily monetized values that we derive from water quality and environmental beauty. Water clarity, biodiversity, recreation. How much can you say a mayfly that's in a stream that would otherwise be removed is worth? It's hard to put a dollar value on that. But some economists from UF-IFAS and environmental economists from UF-IFAS actually did that, and they found that Floridian citizens are willing to pay about $335 million per year to protect the surface water quality of our states. That's beyond the commercial fishing, the ecotourism dollars, or the human health dollars. That's just to preserve the water quality that we have already. So there are a lot of different reasons that we should care about water quality in our downstream ecosystems. And when I think about how we can work on modifying or improving our downstream water quality and link that with urbanization, my mind immediately goes to the urban stream syndrome. The urban stream syndrome is a classic fundamental paper that was written about 15 years ago that talks about how a variety of different symptoms that occur throughout urbanization lead to this overall urban stream syndrome that includes things like physical changes in the watershed. So you have increased impervious surface cover. That's land use or land surfaces that don't allow interactions between the surface and the soil, so water can't infiltrate, like a parking lot, like a house, like a road, like a sidewalk. You have an increase in irrigation usage and a different usage of water throughout the watershed through things like irrigation. You have an increase in chemical inputs for a variety of different reasons. You have a change in the solute or the chemical dynamics dissolved in water. And that leads to physical and chemical changes in the stream itself. So at the top, you see an urban stream and a manhole cover that's to access a sewer line underneath the stream. When that manhole cover was originally put in, the cover was in line or flush with the urban stream. That urban stream has eroded down and now is below the top of that concrete pavement for the sewer access. And that erosion occurs because urban streams are notoriously risky for flooding. You can see the picture at the bottom. That's typically a stream that when it's not raining, it'll be about 3 feet across and flowing really gently. But then if you get 3/4 of an inch of rain in the watershed, like we had on the day this picture was taken, it becomes this raging rapid. That's because the water isn't allowed to infiltrate into the soil and move through groundwater flow paths. And instead, as soon as it hits the streets or the houses, it immediately runs off into the surface water network. These changes in the chemical and physical dynamics of streams lead to biological responses. So we typically expect to see a very few different number of species, and the species that we do see are really tolerant to a variety of different pollutants. They're not the species that are rare, that are really adding to biodiversity regionally. They're species like fathead minnows, shown at the top, or chironomids, which are midges, shown at the bottom, and those can really live anywhere. And so this whole combination of physical, chemical, and biological changes is known as the urban stream syndrome, and that reduces the ability of these streams to protect and preserve our downstream water quality. And so one of the important aspects of urban streams is that they allow us to improve, or they provide some workforce by removing nutrients prior to being exported to downstream water bodies. So I'm asking you all to go to Mentimeter again, and this is going to be a word cloud where I'll ask you to enter some sources of nutrient pollution in urban watersheds, and then we'll talk a little bit about different ways that we can reduce those impacts. Okay. Got one. We do have the profanity filter on. It looks like it's a good thing we did.
Oh, Adrian, we can't see the word cloud.
Oh, you can't? Oh, sorry. Thank you, Sadie. I forgot to hit share. Now we're good, hopefully. But so we're getting a good number of inputs. We see fertilizer, and fertilizer is just really popping up. You see animal waste, sewage, pesticides, trash, dog waste, I imagine, is what's being blocked by the profanity filter, stormwater runoff. Okay, so yard clippings, I'm glad to see that. That's something that people don't often think about. All right, so this is a great word cloud. Keep entering them, but for purposes of time, I'm gonna switch back and remember to share my screen this time. Okay. And yeah, so there's a wide variety of different sources of nutrient pollution in urban watersheds. There's some natural, like rainwater. There's a lot of human derived, like fertilizer, like pet waste, that sort of thing. I'm not here to shame anyone that lives in an urban or suburban house and has a green lawn. If it wasn't so dark outside, I would show you my lawn right now. It's green. I think our landscapers actually just came today. It's an important social component of living as humans, and we derive a lot of benefits from having a lawn or having a landscape. That being said, there are ways to improve the way that we manage our urban landscapes to enhance their ability to protect or minimize their impacts on downstream water quality. Urban watersheds are known to retain a high proportion of the total nutrient inputs as nitrogen, as shown in this picture here, or phosphorus. This picture shows a variety of different pathways for how nutrients move throughout residential landscapes. So 70 to 90%, that'd be a pretty good grade if you were taking an exam, but it's not 100%. So that says that some proportion of what we apply on our landscape is probably going to make its way downstream. So the first and foremost thing that we can do to protect downstream water quality and enhance the ability of urban streams to work for us is reducing our inputs on the landscape. That will increase the efficiency of the broader watershed, and it will just reduce the total potential pollutants that could move downstream. So if there's one thing I want you to take home from this, it's not that you should stop fertilizing, it's that you should fertilize the correct amount. You should fertilize however much you need. You should use pesticides if you need them, but use them sparingly. It's the same thing that I would say if I was talking about pharmaceuticals in the environment. I'm not going to tell somebody to not take a prescription from their doctor, but if they're taking 15 over-the-counter medications and vitamin supplements, maybe you could ease off a little bit on that if they're not needed. So for the rest of this talk, I'm going to be talking about some different strategies and things we can do on our landscape, either individually or as a collective we, in terms of how we develop our urban landscapes. And so to orient everyone, make sure we're all on the same page, I'm going to highlight where we're talking about, because I know a lot of you are probably local Floridians, local Gainesvillians, if that's a word, but some of you might be tuning in from Nebraska or Brazil or Long Island, who knows where. So here on this map, we have Florida, and Gainesville is pinned here in north central Florida. If we zoom in a little bit, this is what the layout of the city of Gainesville looks like. If you squint a little bit, you can see Ben Hill Griffin Stadium, the swamp on the University of Florida campus. If you zoom in even further, this is what downtown Gainesville looks like from overhead. So this is about 600 feet above ground. And what you can see here is pretty much the same thing if you zoomed in on any city throughout the United States or most of the world. You see roads, you see roofs, you see parking lots. You actually see quite a few trees in this picture because Gainesville actually has one of the highest proportions of urban tree canopy of any city in the country. So we're doing a great job there. But what you don't see are any streams, any wetlands, or any natural lakes. And that's in this particular shot, that's because naturally there shouldn't be any in this particular location. But in general, what we're finding in urban areas throughout the United States and throughout the world is that we're turning them into stream deserts. An urban stream desert is a phrase that was coined a few years ago, and it's an area in an urban landscape where there aren't any streams because of human modifications. About 6% of urban areas throughout the United States are urban stream deserts, and that includes 4% of urban areas in peninsular Florida. So 4% isn't a really high percentage. I wouldn't be too worried about that if I was just reading that for the first time, but we'll get back to that 4% number and I'll explain why it could be a really big deal. So instead of having flowing streams in these stream deserts, we have what are known as ghost streams. So ghost streams are kind of what you would think. They're streams that should be there or used to be there, but aren't anymore. They're buried streams flowing underneath human developments. This has been going on since the ancient Romans. So we're very good at, as a society, as humanity, at forcing water to go where we want it and stopping it from going where we don't want it. And one way we do that is simply by building over it. So this figure, this map in the middle is from the New York City Public Library, and it's actually a map of the current underground flow paths of the Gowanus Spring or creek and river network draining into the now surface Gowanus Canal. So it's running under roads and houses and apartment complexes still in New York City. 15 to 20% of the entire European Union streams are estimated to be buried. So that's across all of Europe. We've lost up to 20% of the streams. And this can be really extreme in certain areas. For example, in Baltimore and Detroit, we've lost 60 to 80% of headwater streams. That's not to say that urban areas don't have headwaters though, but instead of headwater streams, we have a different type of headwater. We have downspouts coming off of gutters off of our buildings. So instead of a spring or a wetland draining into a small little temporary stream, we have a gutter that only flows when it's raining. We have a sink that drains into a sewer that makes its way to a wastewater treatment plant that then treats the water and drains into a stream network. So now our sink, whenever we turn it on, that's a temporary stream. That's a headwater stream. We have roads that then drain into stormwater systems that capture that runoff, transport it into stormwater control measures like the stormwater pond. We're designing these things so that we don't flood our houses and our roads. And we're also trying to get some benefits in terms of water quality and biodiversity, or at least recently, the last 10 or 20 years, we've started thinking about that. But there's still ways that we can improve and enhance the way that water moves across our landscape in urban areas. So I'm going to talk about a variety of different small case study examples of ways to improve urban waters, but ultimately it really boils down to we need to slow down water. We need to provide more opportunities for water to kind of be stored somewhere in the urban landscape, and that will allow for increased natural filtering opportunities, increased infiltration, water flowing into groundwater systems, and it also can provide opportunities to maintain, restore, or potentially enhance biodiversity in urban landscapes. The picture at the right is a bioretention cell at the UF Innovation Hub. So that's one example of just a small little urban stormwater management trick that was slotted in with a traditional development, captures runoff from the parking lot, and instead of running directly into the stream, it now runs into this cell where the trees can take up some of the nutrients. So I have 4 different case study examples that I'll very briefly touch on, and they're all spread throughout downtown and southern and a little bit south of Gainesville. They also kind of span a size gradient and an ambition gradient, for lack of a better term. So they're different examples of things that you might be able to do on your landscape, or you might be able to talk about with a stormwater manager or an elected official or something like that. Or you could just learn a little bit about how different approaches can treat our stormwater runoff. So first, I'm going to talk about an apartment complex in downtown Gainesville, the Savion Park Apartments on Southwest 5th Avenue. There's a variety of actually really cool low-impact development strategies that went into this apartment complex, but the specific one that I want to talk about, Dr. Eben Bean, my colleague, is actually squatting on top of right now. And those are the permeable that's the permeable pavement that is lining this road. So this road is not a heavily trafficked road. It's basically a driveway that runs into a parking lot behind the apartment complex. But these permeable pavements, they look like bricks, but they're actually designed to, instead of having concrete where all of the rain would run off the surface into Tumbling Creek, which is about 300 feet downstream, some proportion, 20, 40, 60%, depending on how the permeable pavers are designed, some proportion of that rainwater instead will actually move into the pavement and into an engineered media below there, where it will then infiltrate into groundwater systems. So permeable pavements and other permeable paver options are also available in individual households. You could pave your driveway with permeable pavers. You could pave your patio like we have in our backyard with permeable pavers, and that would reduce the rapidness of water running off the landscape. So the next stop that we're going to visit in this rapid tour that I've actually given a whole day tour using these same stops, but we're going to go through it in a couple minutes, is Depot Park. So anyone that's from Gainesville, you're most likely familiar with Depot Park, especially if you have a young child. Pre-COVID, I would be there basically every weekend on the splash pad with my daughter. You might know it for the playgrounds. You might know it for the amphitheater. You might know it for the hiking trails or the walking paths or the Cade Museum. You might even know it for the really pretty wetlands and water features that they have. But you probably don't know that the actual main intended purpose of Depot Park is stormwater runoff management. Depot Park captures almost all of the runoff, all of the rainwater that falls on downtown Gainesville, and then it treats and removes pollutants prior to exporting it to natural surface water bodies. So it's a really great example of incorporating natural stormwater designs, natural wetland designs into a traditional stormwater management system, while also incorporating additional social amenities and really making this stormwater control and protection of downstream water bodies a central component of the community and really a treasured part of the landscape. Another really awesome but much larger scale project that was undertaken by the City of Gainesville, GRU, and partners is the Sweetwater Treatment Wetlands off of Williston Road. So Sweetwater Treatment Wetlands, you might know it as Sweetwater Wetlands or Sweetwater Wetland Park. It's the most heavily visited park in the City of Gainesville, and it's also the only park you have to pay to get into. So that tells you it's in really high demand if people are still willing to pay to go there. If you're a birder and you haven't been there, you should go there. It's an internationally renowned birding location. You can go out there and see a variety of bird species depending on the time of year, or you could see some baby gators being shown the ropes by their mama. You could see wild horses. You could see a real wide variety of different biodiversity. But if you come with me to Sweetwater Treatment Wetlands, I'd probably take you on a behind the scenes tour, and you could see all of the Gatorade bottles and Polar Pop cups and other trash that's being filtered out of these treatment wetlands before it gets to this more public, beautiful area. These treatment wetlands were specifically built and designed to treat wastewater treatment plant effluent coming out of the Main Street wastewater reclamation facility run by GRU. They had the option of upgrading their treatment plants or building this wetland, and building the wetland not only was cheaper, but it provided the same level of water quality benefits and provided all of these additional amenities. So you're protecting your downstream water bodies while also providing this new addition to the community. So the last thing I'm going to talk about is something that's a project, an idea that was started before I got here to UF, and unfortunately it hasn't moved forward, but I'm hoping that we can maybe raise some awareness and get this back on the docket. But this is the idea to daylight Sweetwater Branch Creek between Southeast 4th and 5th Avenue in the Power District. So this was an idea that was developed by the Gainesville Community Reinvestment Area, and it was to basically take a ghost stream, Sweetwater Branch. It runs through a lot of downtown Gainesville, but then it goes underground for a good portion of its length. The idea was to daylight it and also provide walking paths, eating areas, picnic areas, shopping, etc., on a GRU campus to allow for this enhanced water quality benefits, flood control, that sort of thing, while also providing social amenities. And I think it's important to think about urban stream restoration and daylighting because, well, I'm a stream ecologist, so that's what I really want to talk about. But stream restoration can undertake a variety of different approaches, and it can give you a bunch of different benefits: flood control, water quality, biodiversity. It can also improve or enhance property values close to the restored stream. It can reduce heart attacks and other human health issues. There's a bunch of added benefits to stream restoration. So one example of a stream restoration plan that's still it's still under development, but it's in Jacksonville. It's shown here. So this is the Hogan's Creek watershed. You might have been squinting at this trying to find a creek, and I'll tell you there is a creek here, but you can't see it because it is below ground. It's the Hogan Creek, and a few different groups and nonprofits and Jacksonville municipal government are interested in potentially restoring this creek and daylighting it. And this is a concept design of the Hogan's Creek restoration in Jacksonville via Groundwork Jacksonville, a nonprofit group that's really intent on enhancing the greenness of the city of Jacksonville. So this is another great example. You'd only lose maybe one row of parking, and you'd add this really beautiful stream. You'd reduce downstream flooding, you'd enhance water quality, and you'd provide this bike path, some kiosks for education, a bunch of different amenities. So that's kind of the end of my spiel for the beauty of stream restoration, but I also want to talk about the actual water quality benefits to wrap up here. So this is a picture, or a figure from a study from about 6 years ago in the Chesapeake Bay region, where they're really kind of at the forefront of stream restoration. But they found that buried streams take up about 5 times less nitrogen than open channels. So the bars shown here represent the total amount of nitrogen uptake by different streams, with white bars showing open streams that haven't been buried or have been daylighted, and then the black bars are buried streams. And so you can see the white bars, the open streams, take up a lot more nitrogen than the buried streams. And some work that I did before coming to UF, we also looked at stream nitrogen uptake, and we found that even if you aren't looking at a buried stream, changing how the vegetation and the light that reaches the stream can really affect nitrogen uptake as well. So the figure here, the dark black and the darker gray bars are streams that don't have any light reaching them because there's a bunch of shrubs overgrowing the streams. And then the light gray and the white bars are streams that have open canopies, whether they were restored or not. And we found about a 10-fold increase with light being available, increasing nitrogen removal. So as an extension specialist, I'm always trying to put my work and my research into context and why people other than the stream biologists in the audience should care. So let's think back to what Florida is going to look like by 2070. This is a lot worse than what it is right now. Well, worse, I shouldn't say worse. This is a lot more developed than what it is right now. Right now, though, there's 266 square miles of urban area in peninsular Florida. Of those 266 square miles, about 10.5 miles squared are stream deserts based on a study from 5 years ago. Of those 10.5 square miles of stream deserts, about 9 square miles are land, so we're not missing anything there. About 2 square miles is other missing water. So that could be lakes, that could be wetlands, who knows. But if we're thinking specifically about streams and stream restoration, this 4% of the urban streams missing in Florida that I mentioned earlier, that equates to only 0.2 square miles of missing streams in Florida. So that's the actual surface area of the stream channel of the wetted area. That's a really small number. But if you combine that area, that 0.2 square miles, with the estimates of nitrogen removal from those previous slides that I talked about, those studies from the Chesapeake Bay, that equates to up to 22,000 pounds of nitrogen removal that we're missing from those buried streams every single day. That's 11 tons of nitrogen removal per year. And that's just talking about nitrogen. That's not talking about phosphorus. That's not talking about biodiversity. That's not talking about property values or downstream algal bloom issues. So the last Mentimeter question before kind of a summary, I'm going to ask you to go to the final question and estimate how many homes in Florida would have to stop fertilizing in order to equal the amount of nitrogen that's being removed by urban streams. Okay, so we've got a wide range so far. We are anywhere from, nobody thinks less than 100. Well, one person, okay. 100 to 2,000. A lot of people are really excited and maybe they don't fertilize their houses at all. I should have said based on UF-IFAS recommended fertilization rates. Okay, so we're at about 30. So it seems like people think the majority is more than 1 million. That's giving a lot of credit to urban streams, maybe more than they actually deserve, which kind of pains me to say. But the actual estimate is that would be the equivalent of having 520,000 homes in Florida stop applying nitrogen fertilizer. That's based on UF-IFAS annual fertilizer recommendations. So some people might fertilize more typically, some people might fertilize less, but that's a good ballpark. Beyond that, we get added benefits for removing other pollutants, sediment, phosphorus, heavy metals, pharmaceuticals, etc. We get enhancements in biodiversity. We get added social and human health benefits as well. But just to put this in perspective that I think everybody really can understand, based on a program run by the Florida Department of Environmental Protection, they have a water quality credit trading program where you can pay somebody else to do a practice that will remove nitrogen or remove phosphorus if you have too much nitrogen being exported from your system. So you pay somebody else to take up nitrogen from the same watershed, basically. So I use those dollar values times the total amount of nitrogen being removed potentially by urban streams. And that could be up to $1.0 billion of nitrogen removal from that water quality credit trading approach alone. Again, not accounting for phosphorus or any of the other benefits. So that's, to me, I think $1 billion is a lot of money. I mean, the whole state of Florida, that's a huge economy. That's still not making up for all the ecotourism dollars, but that's a big number in my opinion. So to summarize, we're missing a lot of urban streams. Here in Florida, we're missing about 4%. But worldwide, there's ghost streams and stream deserts, and people just don't even think about it. I found an urban stream in my neighborhood. I've lived here for 3 years. I found it 6 months ago. Like, you just don't even notice them sometimes. The streams that are still around are trashed. There's flooding issues, there's pollutant issues, there's reduced biodiversity, etc. But we can improve urban streams by making improvements in the watershed. We talked about a few different approaches that could either be done in your home landscape, reducing inputs of chemicals, of irrigation water, using pervious pavements as appropriate, or broader, more municipal regulatory practices that can reduce nutrient export. We could also restore streams or daylight streams, and that can really have a pretty big bang for the buck. So ultimately, there's a really large potential for the benefits of restoring urban streams. If you're like me, you probably just think we have an ethical obligation to do so. But I feel pretty good about the fact that we also now can see we have an economic reason to do so. And we have a pretty strong one, in my opinion. So with that, that's all I've got for you today. There's going to be one last Mentimeter question that I'm not going to share with the audience. But if you can go to Mentimeter whenever you have time and type in what you learned today, that would be really helpful for me and for the organizers of this whole program. I really appreciate Chelsea and Sadie and Becca and everyone else who's helped me out with this. And I appreciate you taking your time. If we have any time for questions, I'd be happy to chat more.
Thank you so much, AJ. That was awesome. I wish you could hear our audience applauding for you right now, because I'm sure they are at home. That was awesome. I learned so much. Yeah, we have a few questions here. Sadie, do you want to read us the first one?
Yeah, so if you leave grass clippings on the lawn, does that help the nutrient problem?
Yeah, so leaving grass clippings on your lawn is actually typically a really good thing to do because it really improves your soil quality. It provides an organic matter source for your soil, a food source for bacteria in there, and actually a nutrient source. If you leave grass clippings and just mulch them in, I think that will be a benefit. What you don't want to do is you don't want to blow those grass clippings onto your street or onto your driveway. So either bag your clippings and have them be picked up or leave them on your yard. That's probably the best thing to do. Yeah.
Awesome. So here's a quick question. We just had a question about the watershed map that you showed, the one of the United States. Is that available anywhere online?
It should be. I think I just Google image search watershed map US. But if you can't find it, you can contact either Chelsea, Sadie, or myself, and I can find a link to it. Yeah.
I think I just found it actually, so I'll go ahead and share it in the chat.
While you're doing that, we've got another question. So standing water means more mosquitoes. So how can urban water holding areas avoid becoming mosquito breeding grounds, especially in Florida where mosquitoes and infectious diseases are a problem?
Absolutely. That's a very important thing to think about. There's a variety of different pros and cons to standing water. There's some things that you can do if you have a big water body to keep the water moving around and prevent the development of mosquitoes. You can use things like fountains or bubblers in stormwater ponds. There's also different types, different species of mosquitoes, and I'm not going to talk more about that, but I know certain species like to breed in smaller containers and other species like to breed in broader systems. But ultimately, I think one of the main benefits to this green infrastructure approach is that by allowing nature to kind of take over a little bit, yeah, you might get some mosquitoes, but hopefully you'll get some dragonflies as well. We have a few different stormwater ponds in our system or in our neighborhood, but we don't have mosquitoes at all, but we have a ton of dragonflies, and those are what are eating the mosquitoes. So there potentially could be some issues, and that's something to think about and consider. But in general, I think if it's done well and designed correctly, it's not as much of an issue as people typically expect.
Good to know. Also, any tips for having 0 mosquitoes in your neighborhood? I'm sure we would happy to hear.
I don't know about 0, but not that.
Maybe some of you attended our Science on Tap mosquitoes back in the spring too. So one more question. Can we get you to define restoration again for us? I think different people have different definitions.
Yeah. It's hard to, that's a hard question. Restoration means different things to different folks. I use the term stream restoration in public presentations like this because I think people are more familiar with that term, but I actually don't like it. to me, restoration means trying to return something to its natural pre-development state. And that's not really possible for most of the environments I work in. So I actually think of it more as stream rehabilitation. And that can take a variety of different roles or different ways that can happen. You can make a stream more wiggly so that it has more time to interact with the floodplain instead of being a straight channel. You can just armor the banks to prevent erosion. You can make wetlands along the banks. There's a wide variety of different ways that you can restore a stream. So there isn't a textbook definition, or there's actually probably 20 textbook definitions. So it's hard for me to really say one specific one.
That helps. Thanks. Sadie, do you have another question?
Yeah, we just have a couple of questions that I'm lumping together, but essentially people want to know, how do you generate support for projects like this, like the proposed 4th, 5th Avenue one?
Yeah, well, there's a variety of different ways to go about it. I'm not as plugged into actually generating funding or support for infrastructure changes, because that's more from the city or county municipal regulators, the stormwater engineers, the city planners, that sort of thing. But there are grants and funding available at the state level through state 319 projects that are funded jointly through the state and through the EPA. And I work with some different organizations to develop those proposals and to evaluate and monitor their success. There's also just various incentives and various cost-saving benefits. Like if there's environmental funds for a municipal government, they might say, okay, we're going to actually use these environmental funds to restore the stream. Or maybe some of your utility bill might be going to protecting infrastructure and protecting the sewer lines, and that might take the frame of being a stream restoration.
Great, thank you. Chelsea, did you have one more to add, or?
We're getting a lot of questions in, and I'm really sorry we can't get to them all tonight. You guys have a lot of really tough questions. I knew from that beginning trivia question that we had a smart audience tonight that already came here knowing some things about urban streams for sure. But unfortunately, I think it's 8:02, and we want to be respectful for everyone's time, especially our speakers. So I want to say thank you to AJ for being our awesome Science Off Tap speaker for tonight, and remind you all that we do have 2 more Science Off Tap programs this fall. And I believe Sadie or Elise will be posting a link to the survey for this program in the chat.
Yeah, give me 1 second and I can post the link. We really appreciate everyone taking the time to give us some feedback. And yes, thank you. AJ put also his contact information in the chat. So if you have more questions, I'm sure he would be happy to answer them. All right, I just dropped that evaluation link in the chat. Thank you again for your time, everyone. Thank you to our speaker, and we hope you all have a wonderful night.
Yep, thank you. Bye.
Bye.